Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability and Statistics, and we are on to the topic two-dimensional random variables. Here we have a problem. In the previous classes also we have seen some problems regarding the two-dimensional random variables within the given range, and here we have an extra question that we have to check for the independency concepts of both the random variables x and y. The joint probability density function of a bivariate random variable. Bivariate means two-dimensional. Random variable x and y is given by f of x comma y is equal to k into xy, where 0 is less than x less than 1, 0 is less than y less than 1. And we can also note that it is 0. The probability density function is 0 otherwise. The first question is we are asked to find the value of k. The second question is we are asked to find the value of probability of x plus y less than 1. And the third case we are asked to find, or we have to check for the independency of x and y. Given that the probability density function f of x comma y is equal to kxy, where 0 is less than x less than 1 and 0 is less than y less than 1. X's range is 0 to 1, 1 is missing here, and y's range is 0 to 1. Both of the variables are having both the ranges as 0 to 1 and 0 otherwise, which means in all other places the value of f of x comma y will be 0. So moving on to the first case. What is our first case? We are asked to find the value of k. We are asked to find the value of k here. What is the value of k? How to find the value of the constant for the given probability density function, which is double integral minus infinity to infinity f of x comma y dy dx is equal to 1, which means the total probability is always equal to 1. So this is the case we are going to take. So this total probability I am going to consider for the continuous random variable, and this is what we have got as the formula to find the value of the constant when a constant is there on the probability density function. So integral minus infinity to infinity f of x comma y dy dx is equal to 1. Double integral 0 to 1, since we have the x's range to be 0 to 1 and y's range to be 0 to 1, k of x comma y dy dx is also equal to 1. And since k is a constant, and on integrating it with respect to the variable y, we have y squared by 2 and x is treated to be a constant here, and dx remains the same and it is equal to 1. In a similar way, moving on to the next step, we will just have this x value to be integrated here. X's integration is x squared by 2. We have a 2 in the denominator already, therefore 2 into 2 will be 4. And on applying the definite limits here, we will be having the value of k to be 4. We will just have to use this particular formula to find the value of any such constant given in the PDF probability density function. So moving on to the second question, what we are asked to find the probability of x plus y less than 1. In the previous case also we have seen some problems related to it. If we will be just taking this condition as this given condition as is equal to 1, x plus y equal to 1, so that x is equal to 0 to 1, y is equal to 0 to 1. X is equal to 1 to 0 to 1 minus 1, y is equal to 0 to 1 will be the range for the given question. So what will be the thing? We will be having the double integral within the range minus infinity to infinity. Within the range minus infinity to infinity means we will be applying the x's, y's range here and x's range here. But here we have the x's and the y's range to be a constant value here, and therefore we will be taking x order of integration first and y order of integration later. So probability of x plus y less than 1, which will have the range to be integral 0 to 1 minus y 4xy into dx dy, since we have substituted the value of k here, which is 4. So we have just substituted the value of k here, 4xy into dx dy, and on simplifying it, mere simplification and integration, we will be having the value of probability of x plus y less than 1 is equal to 1 by 6. So this is how we complete a problem on probability of x plus y less than 1 regarding the two-dimensional random variables. So what is our next problem? Your question is to check if x and y are independent or not. So for independency, we will just have this condition. What is our condition? If the two random variables are independent, it should satisfy this property. What is this property? F of x comma y is equal to fx into fy. What is f of x comma y? It is a probability density function. The given probability density function should be equal to the product of, what is f of x? F of x is nothing but mdf of marginal density function of x, and f of y is nothing but mdf of y. So this is how we are going to find the independency concepts of both the problems, both the random variables. What is f of x? F of x is equal to integral minus infinity to infinity f of x comma y dy, since here we are fixing x and varying y. In a similar way, if we are about to find f of y, we have to fix y and vary x. So what will be the range of y here? Since we have fixed x, the range of y will be integral 0 to 1. And therefore, on simplifying it, we will be having the marginal density function of f of x to be 2x. In a similar way, we are going to find the marginal distribution function of f of y. In here, as I have said earlier, we have fixed y and varied x. If we are varying x, we will be having the range for x, which is 0 to 1, and simplifying it, we have 2y. And on checking for the independency, the LHS will be f of x comma y as per the given question, and f of x into f of y, and multiplying it, we will be having 4xy, and therefore we will be having LHS is equal to RHS, and therefore what we can say that x and y are independent, which means both the variables are independent, which does not depend on any of the other variables. So likewise, we will be finding the independency for both of the variables, and we will continue this problem in the next video. Thank you.